Hello friends, welcome to the YouTube channel, Bots Meets Brains. Today's topic is what are LLMs and how are they trained? Every day, you probably interact in LLM even if you don't know it. They write your emails, help with homework, generate images, and even hold conversations that feel shockingly human. But what's behind this magic? Welcome to today's deep dive into the world of large language models, or LLMs for short. In this session, we will cover two key points. Firstly, let's understand basics of LLMs. And secondly, we will understand how are they trained. Without more delay, let's jump into basics of LLMs. Alright, before we go deep into the nuts and bolts, let's start with the basics. What exactly is a large language model? And why is it called that? It's called large because these models have large number of parameters. How large, you say? Well, an LLM like GPT-3 is trained on 175 billion parameters. GPT-4, although not officially declared by OpenAI, is rumored to have 1.5 trillion plus parameters. These parameters are trained on large number and amounts of data. This data is collected from public websites, books, articles, code repositories, and other written materials. So large number of parameters getting trained on large amounts of data, hence large. The reason why these models are trained on such massive volumes of data is to give them a wide variety of language patterns, topics, and writing styles. Now, jumping to the language part. Why is it called a language model? It's called a language model because language is its key skill, and its core purpose is to actually predict and generate human-like language. 2. How are they trained? Training is a four-step process, starting with data collection, then tokenization. Tokens flow into the transformer architecture, and then comes the actual training. Step 1. Massive data collection. LLMs start with data, a lot of it. For traditional language models, this means text from books, articles, websites, code repositories, and more. The goal is to give the model examples of how language is used in all kinds of situations. When I say data collection, I don't mean the AI is roaming the internet with a little shopping cart. It's actually the engineers and researchers behind the scenes, using automated tools and partnerships to pull in huge volumes of text that will feed into training. Now the question is, what happens to all this data? How does an LLM process this? This brings to our step number 2, tokenization. Fundamentally, tokenization is the process of breaking down raw text into smaller units, tokens, that a computer model can process. This is critical because computers don't understand words. They work with numbers. In short, tokenization is the bridge between human language and machine-readable numeric data. This is done by a special piece of software designed by data engineers and machine learning engineers called Tokenizer. It basically knows how to break text into chunks. This tokenizer is created before training begins and becomes a permanent part of the model's language system. During the training process, all text is first run through the tokenizer, which converts it into numeric IDs. Tokens created could be like a whole word, dog, part of a word, un plus happy, a single character, mine A, or even punctuation marks, comma. The exact definition depends on the tokenizer's rules. Just for perspective, here's how this is typically done. Let's take some text, for example, the sky is blue. When broken into tokens, this would look like this. From here, the tokens are converted into a unique numerical IDs. These IDs are fed into the neural network. What is worth mentioning here is that tokenization doesn't understand meaning. It's just slicing and labeling text in a consistent way, so the model can learn patterns from numbers. Now that the massive data is collected and converted to tokens, where does this go next? That brings us to our step number 3, the transformer architecture. At the heart of an LLM is a neural network architecture called transformer. Transformers have an ability called attention. It lets the model figure out which words should it focus on most in order to understand this sentence. Let's understand this with an analogy. For example, in the sentence, "The cat sat on the mat because it was tired," the word "it" clearly refers to the cat, not the mat. Attention helps the model make that connection, even across many words. But attention isn't used just once. Transformers are built from multiple layers of attention plus processing, stacked on top of each other. Each layer builds on the last, catching more complex relationships and abstract patterns. Think of it like peeling back layers of meaning. The first layer spots simple word links. Later layers grasp style, tone, or even intent. This brings us to the final step of how is the training actually carried out. Step 4. The actual training. The training, put simply, is a cycle of guess, check, adjust, and repeat. We have 2 key participants in the training process, the trainer and the student. With reference to what we are discussing, the trainer is the training software, and the student is LLM. Now, let's break the training process down into smaller steps. Let's look at the example earlier. The cat sat on the mat. First, the training software like Hugging Face gives the LLM a sentence with one word hidden. The cat sat on the target, mat. LLM has to now make a guess, also known as forward pass. It does that by assigning a probability to every token in its vocabulary. Let's say it assigned the following probabilities. Mat, 0.42, 42% likely. Dog, 0.20. Floor, 0.15. Other tokens, tiny probabilities. After the guess comes check, also known as loss function. Training software compares the guess with the ground truth, mat. Uses cross-entropy loss to measure how far off the prediction distribution was from the correct answer. Finally comes the adjust, also known as backpropagation plus optimization. The training software calculates gradients and tweaks billions of parameters via Adam W or similar. Repeat billions of times with new sentences. At the end of this process, your base model is trained. What if you want it to specialize in a specific field? What could be the next step? Step 5. Fine-tuning. Once the base model is trained, it can be fine-tuned for specific purposes, like coding help, legal writing, or customer service. This involves feeding it extra, specialized data pertaining to the field you want the model to specialize in. So let's recap what all we learned in this video. Basics of LLMs, why are they called large, and how language is their key skill. We then went deep into the training process and its 5 steps: data collection, tokenization, transformer architecture, actual training, and fine-tuning. Thanks for watching our deep dive into how large language models work. If you enjoyed this video, give it a thumbs up and hit that subscribe button for more such AI explainers.